Okay, so far we have configured the trunk interfaces here. I'm going to configure some of these PCs with IP addresses and put them inside their respective VLANs. Like I said, 20 and 30. Green is going to be 20, red is going to be 30. This means that I should configure the Ethernet interfaces connected to these PCs on the switches with the respective VLAN ID. So let's do this. I'm going to start with PC 30. And PC 30 is going to have an IP of 1010. 20 is going to be the VLAN ID, and then 230 is going to be the ID for IP address for the interface for the PC /24. And let's say that the gateway is going to be 1010/20/254. Although for now I have not configured any gateway, but let's say that this is the gateway that we are going to configure here. So hit enter, and later I'm going to configure VLAN routing on these switches. So I'm going to save the configuration so that I have this later without any problem. So 31 is in VLAN 20 again. So I'm going to say this is going to be 231. And then I'm going to save. And for this is going to be VLAN 30, which is going to have this gateway IP address. This is 232, and the VLAN ID is 30. I'm going to save this configuration. And also the other one is in VLAN 30 as well. But the only thing is the IP address, which is 233. Okay, now that I have done this, it is time to configure the interfaces with the respective respective VLAN ID. So let's go to switch 1. On switch 1, I'm going to go to enable mode and then to configuration mode. And I'm going to say Ethernet 4, which is connected to here. It's going to be a switch port interface. In bridge group number 1, switch port mode is going to be access. And switch port access is going to be in VLAN 20. So that's it, and I'm going to commit the configuration. So this interface is going to change the topology a little bit because we have not configured anything like port path, and that's okay. But for now, that's going to be what I'm going to do. On switch 2, Ethernet 2 has this configuration. So I'm going to copy this configuration, and then go to switch 2. I'm going to say configure terminal interface ETH2, and then this is the configuration, and I'm going to say commit, which converts the candidate configuration into running configuration, and then I'm going to save this to the configuration that we have here. Okay, now on switch 3, of course, this is going to be a little different. So let me do this. I'm going to paste this here. Both of them are interface ETH2. So both of them are in VLAN 30. Then I'm going to commit the configuration. So let's go to here and say en conft. So I'm going to copy this configuration, go to switch 3, and do it. So interface ETH2. Okay. Here's the problem. It should be like this. So let's exit. And one more time. This time we have no problem. On switch 4, the same thing. What I'm going to do is just to save the configurations so that I do not miss anything to WR. Okay, now that we have done this, we should be able to reach to other PCs from, let's say from PC 30, I need to be able to reach to PC 31. From 32, I need to be able to reach to 33. So on PC 30, what I'm going to do is to say ping 10, 10, 2231, and this is accessible. And obviously I cannot reach to the others because I have not configured VLAN routing, actually inter VLAN routing. But again, this is possible, and from PC 32 I should be able to reach to 10.10.32.33, which is quite possible. So this part is done. One more thing that I'm going to configure in this video is the interlinks between switch 5 and switch 6. For now, I'm not going to configure any link aggregation. What I'm going to do is to just make sure that Ethernet 4 and Ethernet 5 both are in trunk mode. So let's go to here. I'm going to say Ethernet 4 and bridge group is 1, and this is going to be in trunk mode, and switch port trunk, I'm going to say allowed VLAN is going to be all. And I'm going to do the same thing for Ethernet 5 as well. So I'm going to do this, then I'm going to commit this. So let's go to switch 5 and switch 5. So this is done. On switch 6. Okay, this is done. So now we have configured these interfaces as trunk, which means that now we have a looped topology here, as you can see. Okay, and this is kind of inverted view. Very good. Now let's go for some verification commands. Let's go to switch 1, for example. And what I'm going to do is to say end. I'm going to say, first of all, show spanning tree. This means that for all the VLANs and for all the interfaces, I'm going to receive some information. Let's check this information. Some of the very important parts are here. So the bridge is up, spanning tree is enabled, topology has changed. We have changing topology, of course. The root path cost is 500 for now, and the priority is by default 32,000 out of 64,000 actually. And some information which is very important. The forward delay is 15 seconds. This is the default, of course. The hello timer is 2 seconds. Max stage is 20 seconds, which is 10 times more than hello timer. Transit hold count is going to be 6, and root port is going to be 3. This means that the ID of the root port is 3. Okay, so the root ID, this is the MAC address of the root switch. And if this is the same as what we have as bridge ID, this means that we are the root right now. As you can see, this is exactly the same as what we have. No, this is not the same because this ends in F201, but we are F001. So it doesn't say, like Juniper switches, it doesn't say that this is the root bridge, although on Cisco switches you see that, and that is a good indicative of what we can, what we would see here. But here, as a matter of fact, I need to just compare this. At least that's a little hard visually, but you can see that this is not the root switch. So what is this F201? I can just check them and see them later. But let's just check the rest of the information. So far we have had 5 topology changes, and you can see that some of the features such as port fast is disabled, and BPD guard, BPD filter are disabled as well. Okay, now we are going to see information for each one of the interfaces that are connected to different devices or their trunk. For Ethernet 1, it says that the port number is 3, and Ethernet 1 is connected to switch 6 actually. And it says that this is root port. Root port is number 3, like I said. Now we know that the root switch might be switch 6. And I can just show you that this is the case. If I go to here and say show spanning tree, it says that, oh no, this is not the root. It says that I am F901, but the root is F201. So let's see which one is the root. To show spanning tree says that I am F801 for this. To show spanning tree says that I am F301 on this. to show spanning tree says that I am F201. So switch 3 is the root switch, although this is not a good placement. I need to change this, and I'm going to show you how we can change it in the next video. But for now, you can see that switch 3 is the root switch, and switch 1 goes to switch 6 and then gets to switch 3 as a root switch. Okay, so let's go back to switch 1 and see some more information. As you can see, we have some information about the cost to get to the destination. In the beginning, it says that the route path cost is 500, but the port cost is 250. Based on this, of course, I could have guessed that there are 2 hops to get to the destination, which is switch 3. So these are the small information that you can just check and just get some information for that. And here on Ethernet 1, it says that the designated route is this one, 201, and the designated bridge is 901. And you know that 901 for now is switch 6, based on what we see here. Okay, so now we know that we have to go through this port to get to the destination. What about the other interface that we have, Ethernet 7? That should be interesting to check Ethernet 7 as well. So if you just go to here, on Ethernet 7, it says that the state is blocked, and this is the expected behavior from what we have, because this is the root port. This is going to be in forwarding, and the rest of the interfaces should be blocked because we don't really want to have any loop. In case we have a loop, what is going to happen? This is going to go to switch 6, and I know that these ports, this side should be blocked, otherwise the frame would go to here and then would go back to switch 1. But if I just go to switch 6, I expect to see Ethernet 4 and Ethernet 5 as blocked. So let's do that. I'm going to go to switch 6, and then I'm going to check Ethernet 5 and Ethernet 4. Ethernet 4 says the state is forwarding. Ethernet 5 says the state is forwarding, which is interesting. And on switch 6, of course, these are in forwarding state. What about switch 5? If I just go to here and check Ethernet 4 and 5, it says that the state is blocked. That's good. Now we know that these two are in forwarding because switch 5 should receive some BPDUs from here, but the actual port does not forward any data. The only thing that it does is just to send some BPDUs here, and the reason for that is because switch 3 is announcing itself as root. It sends BPDU to switch 6, and switch 6 is going to forward that BPDU to other devices like we have in normal spanning tree configuration. Okay, so now I have seen some information which is important. Like I said, the most important part is going to be the state of the link and the role of the link, which can be designated or root. Root just points towards the root bridge. Designated points toward the bridge that kind of takes us to the root bridge, as a matter of fact. Okay, so let's see some more information. What I'm going to do is to say show bridge and hit enter. And based on what we have, you can see that we have some of the ports with some configuration. Normally, in your production environment, you shouldn't see so many unknown ports. What you should see is just the ports that are configured here. For now, for example, I see Ethernet 8 on switch 1 and the loopback interfaces, which is configured for us. But there should be some more information after some time, and we should collect some more information here. The other thing that I want to do is I can just go with show interface, and after that you can see that we have brief and switch port. Switch port is going to give us some information about layer 2 properties of an interface. So here you can see that it says, for example, this one is Ethernet 7. The bridge name is 1, of course. The switch port mode is in trunk because Ethernet 7 is a trunk link. And we have some default VLAN, which is VLAN number 1. We are not using it. We have used VLAN 999 as management, and the other VLANs which are active on this interface, of course, are 10, 20, 30, 40, and 50, and 999. And the same information about all the other interfaces that we have here. And also, if I just say show interface brief and hit enter, this is going to give us some more information again. You can see that these are the IP interfaces that we have. Normal interfaces that we have is VLAN interfaces. So one of them we have configured IP address, and you can see that some other interfaces are in down state. And the reason for that, of course, based on what we have here, is that is management Ethernet. Like I said, Ethernet 0 is not used in my topology, and that's because this is normally used for management, but I have not used Ethernet 0 for management. I'm using a VLAN for management, and for each one of those switches, I have a VLAN interface for that specific VLAN. Okay, so now we have done this, and we have checked spanning tree situation. Later I'm going to do some modification to my spanning tree in this part of the network.